Bueno, pues ahora sí, de nuevo, bienvenidos, muchísimas gracias a todos ustedes y precisamente estamos listos para abrir el tema de la industria médica. Quiero comentarles que este sector cuenta con una gran variedad de ejemplos de éxito aquí en nuestra ciudad de Tijuana, desde los componentes para marcapasos o los termómetros digitales que exportamos al mundo. La industria médica en Tijuana se abre paso como una de las más sólidas en el país, ya que genera alrededor de 28,000 empleos directos. Pero bueno, pues ¿qué les parece si para entrar en este tema con los expertos voy a presentar precisamente nuestra primera conferencia de esta tarde, que está a cargo del señor Nordhoff. Él es presidente del consejo de GenPro, compañía con base en la vecina ciudad de San Diego, en la cual se integró en el año de 1994. En ese mismo año fue nombrado director ejecutivo, se retiró de este puesto en el 2009 para convertirse en presidente del consejo de GenPro. Esta compañía es líder mundial en el desarrollo, manufactura y mercadeo de productos moleculares y servicios utilizados para el diagnóstico. Áreas muy especializadas que incluyen apoyos para la investigación biomédica. Vamos a recibir, por favor, con un fuerte aplauso al señor Nordhoff.
Thanks, Claudia. Thank you very much. Thank you.
Thank you.
Thank you, Claudia. Good afternoon, everybody. It's a pleasure and an honor to be here today to talk about biotechnology. We're going to start because I will end up using GenPro, the company that I ran for about 15 years, as an example of a successful biotech company, and it is a public company, so I have to go through this for the SEC. A safe harbor statement. I may talk about the future of GenPro. If I do, there's no guarantee that future is going to happen. And non-GAAP financial measures. Every time the U.S. accounting authority changes a rule, if you didn't use the rule before they made it, you're non-GAAP. And GAAP stands for Generally Approved Accounting Principles. So we will use some non-GAAP for historical comparative purposes, and I'll point that out when we do. Down to business. I'll talk about biotech, what it is, how we use it, and how it became an industry, and is only about 35, 40 years old. We'll talk about the biomedical part of biotechnology in California. We'll talk about the Cali-Baja mega region and what's going to happen. And then finally, I'll talk a little bit about GenPro, the sort of biotechnology that it uses, why it's been successful, and what it's going to do in the future. Now, I'm pleased to see some students here, and there is going to be a lot of technical jargon, and I hope at the end of the day, many of you decide to find a job and play a role in biotechnology. And I think you'll see, even at my presentation, which is unprofessional, how interesting it can be. And for everybody, we're going to have a little quiz at the end of this, and you can't leave until you get all the answers right. And this is the first question. What is biotechnology? And it's a tough one to answer. I mean, essentially, biotechnology is taking something from a biological environment and making it do something that it hasn't done before. So technology that uses biological systems, living organisms, or derivatives thereof to make or modify products or processes for a specific use. I'm going to give you an example of what that means in a couple of minutes. These are some of the applications of biotech. Almost anything you can imagine uses biotech. And I even see down there that there's computing, using cells as storages for memory of information in the future. So biotech has its tentacles in many, many areas. I think the most important and interesting applications are only three: food, medical, and industrial. And food used biotechnology roughly 8,000 years ago. They use enzymes to take some grains, which they cooked in water, put the enzymes in, maybe a little yeast, and out came beer. So beer and bread, probably the two oldest. I understand that about 600 years ago, a person in Mexico took an agave plant and fermented it and got tequila out of it. Another example, fermentation is the use of biotechnology for foods. Today, they're taking corn, they're taking rice, they're altering the genes of those foods so that they become more drought resistant, more resistant to disease and all the rest of that stuff. So it's very modern stuff. I know in Europe, people are very much opposed to eating what they call GMOs, genetically modified organisms, or food that's been modified a little bit. And I think ultimately we'll accept all of that. On the medical side, the medical applications of biotechnology started probably 40 years ago. And the first product is insulin. Insulin we used to get from animals, and there were questions about purity. So they took the gene for insulin, put it into E. coli, a fairly common bacterium, and produced insulin. Phenomenal. Again, taking an organism, using it for a purpose different than that for which it was intended. When we talk about GenProbe, you'll see that we use little pieces of DNA in order to identify infections. Another use is monoclonal antibodies. Many of you my age or older will remember monoclonal antibodies were called the magic bullet. They will bind to certain receptors on the surface of certain cells. Now that started about 40 years ago, and about 30 years ago I was running a monoclonal antibody company. And we had a long way to go before it became practical. We found out that when you put a monoclonal antibody, and antibodies are the body's first defense against infection. When you have a bacterium, any sort of a germ that the body recognizes as foreign, it will generate antibodies to that will only bind to that specific organism. And when it binds, it's like raising a flag on it. It alerts the immune system, the macrophages will come and destroy it. So we then use those antibodies as a targeting agent. We had to take a lot of the antibody apart because the human immune system recognized that as foreign and just used the binding site. And we're using it to treat cancer. And I think one very interesting application is taking a monoclonal antibody or a part of a monoclonal antibody that will bind to receptors on the surface of prostate cancer. Taking that antibody and attaching to it a little piece of magnetic iron oxide. And the magnetic part is very interesting. So you can inject that into a person. It'll go directly to the tumor and bind only to that. Now, interestingly enough, the tumor cells for prostate cancer are very sensitive to increases in heat. Our body is about 98.6 Fahrenheit. If the temperature of those cells gets higher than 101 degrees Fahrenheit, they die. So you take the antibody, you take the little piece of magnetic iron oxide, put it in the body, it goes to the site, then you put it into a field, oscillates, and the magnetic thing gets hot, raises the temperature, and kills the cancer cells. Now this is still in development, but I think holds tremendous promise. So that's a combination of nanotechnology and biotechnology. And then finally, industrial. Awful lot is happening in the industrial side. A fellow I know fairly well, Craig Venter. Craig is the one who first sequenced the human genome. Started a company recently called Synthetic Genomics, and they're working with algae as a source of fuel. They just signed a deal probably less than a year ago with ExxonMobil, who gave them $600 million to develop this. So what they're doing, they're taking algae, and algae grows fairly rapidly in the presence of carbon dioxide, sunshine, and water. And Craig and his people are messing around with genes to try to get one that grows fastest, has the highest yield. And a gentleman who is at ExxonMobil made the comment that the oil that you can get from this algae is very similar in molecular structure to petroleum. And he believes that they may be able to take this oil and put it in the same refineries that they currently use to get gasoline and diesel fuel. And that would be fantastic. And I think would be a very interesting area for Mexico to get involved in. Now, as you probably know, they've been modifying corn for ethanol, the food type that we talked about before. But it turns out to be not economic. It's too expensive, requires too much land and all the rest of it. The algae is terrific because you can grow it in salt water, and I think Japan is trying to do that now. And you can also grow it in fresh water, and the quantity and the quality of the water doesn't make too much difference. So these are all, I think, very exciting applications for biotechnology. So we just did the biotech overview, and now we'll talk about the California biomedical industry. Now, I know it's not going to be very impressive to the students, but for those of us who have run businesses and started businesses, these numbers are impressive. Again, there was no biomedical industry in California 35 years ago. Only one company, and that was Genentech. Right now, there are 2,000 companies in California with total sales of about $76 billion. Employees total about 274,000. Now that doesn't include the employees who work to provide services and products to those companies. And those employees probably total twice that amount. So biotechnology, biomedical companies, both directly and indirectly, employ about 750,000 people. Wages and salaries paid, about $20 billion. Now, if you divide the $20.5 billion by 274,000, you get an average wage of about $75,000. And that's the average wage. We'll see a little bit later that different sectors of the biomedical industry have different wages. The biopharmaceutical part, average wage, and that's just salary and overtime, if you will, but doesn't include bonus or any money you can make from stock options. In the biomedical field, the average wage is $108,000 per year. So that's not bad. The grants that were awarded to California Biomedical, $3.2 billion from the NIH, the National Institutes of Health, and that's about 40% more, and California received more money than any other state, than the second largest recipient, and that would be Massachusetts. Venture capital, about $2.6 billion. Unfortunately, with a downturn in the world economy, venture capital is slipping because these investments are considered fairly risky. And most companies, most of those 2,000 companies, the startups, won't make it. They'll last a period of time, they'll run out of money, or their technologies just will not be appropriate for what they want to use it. And the total biomedical exports, about $17.5 billion. So quite a nice picture. And I think all of that is possible in this area. When we talk development, we talk about clusters. And the clusters usually form about a university or a research institute. Some technology or products come out of there. Some entrepreneurs decide to license it out, try to raise money to develop it. And this forms a cluster. San Diego is one of those clusters. San Diego has, in terms of biomedical employment, about 24,000 people. And there are 7 clusters in general. I quite honestly was surprised to see Los Angeles so large. I always thought that San Francisco and San Diego were the largest clusters. But in terms of employees, not in terms of companies, which would be different, Los Angeles is big because of Amgen, arguably the first or the second biotech company, which is located in LA, and Baxter and some other companies have big production facilities. But generally, a cluster will form around science, products, and people. The employment by sector in the California biomedical group, the largest would be medical devices, instruments, and DX